Okay, so this is my recording for assignment two of the Python programming class, the coprime assignment. So this is sort of the code overall. There's two functions, there's coprime and then coprime test loop. I'm going to go over coprime because this is sort of the big theory of it, right? So while looking into what a coprime is, I sort of use Wikipedia firstly to kind of check what it actually is, and I saw that I have to look for some common divisor, right? I have to make sure that that common divisor is only one. So the way that I did that, I kind of looked up how to look up a common divisor, and I found this Euclidean algorithm, and this kind of calculator kind of shows most of it. Now there's no code. I didn't take any code from this, but there's sort of a pattern here. For example, if I want to check Euclidean algorithm and then 9, 8, all right, I calculate that. I can see the GCD of the numbers are 1, right? And it shows right here how they summarize the algorithm. They basically made sure that they took the divided with the 2 and then made sure that the remainder is 1. And you basically keep doing that until the remainder either hits 0 or just or it hits 0, and thus the divisor is 1, or they just kind of keep going. So and that's really the algorithm that I used for most of this. And that's, you can see in here. So we're going to firstly take the remainder of the two integers, a and b. And while taking those remainders, we're going to go ahead and make sure that the remainder isn't less than 0. So basically, if instantly the remainder is 0, we know that's inherently false, right? However, once we take that remainder and we make sure it's not 0, we're going to go ahead and re-grab that remainder. So that each time we are within this while loop, it kind of redoes the remainder function of this. Now, perhaps this might be redundant. I haven't really thought about it much. I was thinking about it while coding, but I think this is necessary while looping to kind of continuously get a remainder going. And that's basically what I did. So then you set the a to b, and you're basically taking that b and then dividing that again with the remainder, right? So if the remainder isn't 1, meaning that we haven't found that it's the greatest common divisor is 1, then we're going to keep going and we're going to loop. We're going to loop. Now, if we get less than 0, then or we never hit 0, right? Then we're just going to return false. And we're going to see that within the coprime test loop, where we're going to set a flag here, and while the flag is up, we're going to get the inputs as integers, and then we're going to send it through coprime. And then if that coprime returns 0, then it's true, or 1, then it's true, right? We know that these two are then coprimes. However, if we don't, then we're going to print that they're not coprimes, and we're going to keep doing this with a not continue or a continuous continue. And so basically, let's say I do 9, I'm going to input the second number, and then it does 8, right? And this is going to ask me, well, it tells me that they are coprimes. Okay, well, would I like to continue? Let's say no, right? And it exits then. And that's how I do it. Now, how efficient is it? I talked about here, perhaps this isn't as efficient. I haven't really gotten another answer that I've gotten right, and because of time, I'm just going to assume this is the best that I could do. There's probably a better way. I haven't figured it out. And then the assumption that the code makes, for example, it assumes that the user isn't kind of randomly writing things. So I write A, right? This kind of breaks it, and write B. So I haven't tested all of those and made sure those cases are okay.